For C, taking 4i and multiplying 12 minus I. Now, since I do have the complex number 12 minus I having two terms, I am going to have to use a distributive property here, which means I'm going to do 4i times 12 and 4i times negative I. Which means I'm going to have 4i times 12 minus 4i times I, which gives me 48i minus 4i squared. Now, I have some students who will make the error and say, well, I'm going to stop right there. The problem is, you can't. Remember, these are closed number systems. If 4i, even though it's all imaginary, is a complex number. If I take two complex numbers, namely 4i and 12 minus I, and multiply them together, I should get another complex number, which means I should be able to write it in a plus bi form. So I do have to make sure I have it in that form before I call it done. And here's how I'm going to make sure it gets put into that form. So I do note this is not standard form for a complex number. So I know that I squared is negative 1. So I have 48i minus 4 times negative 1, which becomes 48i plus 4. And by the commutative property of addition, that's the same thing as having 4 plus 48i. So that's the final answer. So you should always have a number that has that a plus bi form when you're done. If you don't have it in that form, you have not finished the problem. This becomes more important when we do these multiplications, especially when we take two full-fledged complex numbers and multiply them together like we see in Part D. 10 minus 3i, complex number, has both a real and imaginary part. Same thing with 8 plus 5i. When I carry through the multiplication with this, since they each have two terms, I am going to FOIL. So I'm going to do 10 times 8 and get 80. I'm going to do 10 times 5i and get 50i. I'm going to do negative 3i times 8 and get a minus 24i. I'm going to do negative 3i times 5i and get a minus 15i squared. Now as I work this through, you notice that first of all, I do have some like terms. I do have terms that have I in it. I also have an I squared term, which should never appear in a final answer because that's not part of that a plus bi format. It's, I don't have a plus bi plus ci to the second power or some other power. It's just a plus bi, where a and b are real numbers. So I'm going to take into consideration. I'm going to group things together, realizing that I squared is the same thing as negative 1. So I am going to have 15 times negative 1, which is just a real number itself. I have 50i and minus 24i, which are two imaginary numbers. So I just rearrange this so that I add my two reals and my two non-reals together. So negative 15 times negative 1 becomes a plus 15. So I have 80 plus 15, which is 95. And I have 50i minus 24i, which becomes 26i. So the final answer is 95 plus 26i.